Hi, this is Joe Maciarz from Tutoring Enterprises. Today I want to continue a discussion I started last time. And last time we were talking about the linear equation standard form, and I said that we had something special that wasn't in the books, and it's called the Intercept-Intercept form. It's going to have two parameters in it, a and b, and we're going to look at what those things do and how the equation works. So let's hustle over to the graph now. Remember that the original equation that we were talking about was something in the form of ax plus by is equal to c. Now, because I haven't defined a, b, and c, it's going to give me an error, and we don't really care because I was just looking at this mostly. But what I want to point out is that we can actually figure out a way of dealing with this a little bit better from this equation. Very specifically, what we'd like to do is get a 1 right here. Now, how do we do that? Well, of course, we could, like if this was a 6, we could subtract 5, but that's not really going to be very helpful because either way, this is the constant term, and we really wouldn't be changing it. Even if we subtract 5 from both sides, all we're doing is putting part of it on the other side. We want to keep 3 terms and only 3 terms. So the only other way we can make this into a 1 is by dividing that term by c. But whatever we do to one term, we're going to have to do to all the others. Okay, so in other words, we're now going to have a form of a over c times an x plus a b over c times a y will equal 1. Okay, and again, we're getting an error because of a, b, and c. Now, this is still not quite the form that we're looking for. And I want to basically talk about something before I manipulate this. And I want to ask you a question. What would you do if we had something like, oh, let's call it 5 over 2 over, well, it's not doing it that way. Let's do first 5 over 3. Let's do that. But let's change the 5 to 5 halves, and then change the 3 to 3/7, something good like this. You remember this in the nightmares of your 4th and 5th grade? This is a fraction over a fraction. And we had a very specific way of dealing with this particular one. You might recall the words flip and multiply, or multiply by the reciprocal. So what you do is you basically take 5 over 2, the top with that fraction in it, and you're going to multiply by the reciprocal of the bottom. In other words, we're going to flip it. So we would be multiplying by 7 over 3. Okay? And then from there, you would just multiply further. You'd say, well, that's 35 over 6. Okay? That is one way of dealing with various types of things like this. Now, we're going to want to get rid of the a and the b on top. So I'm going to point something out to you. Let's keep that there. It's, again, not going to be a valid equation, but that's okay. We're just going to keep this here to look at it. Now, suppose, again, instead, I had something else like this. Suppose I had x over, let's go with 5 halves. Let's go with that. What could I do with this? Well, remember that we can treat a number like 7 as a fraction. That is, we can say that 7 is equal to 7 over 1. Likewise, we can say 11 is 11 over 1. But we can do the same thing with variables. So the x that's on top here, this x, we can treat as x over 1. So let me do that. Let me first, though, divide the x by 5 over 2, and then we'll divide this by 1. So we haven't changed anything. We've just made the x that we had x over 1. And if you think about it, x over 1 is x, so we haven't changed anything. But now, look at what we did here. We had the 5 halves divided by the 3/7, and we flipped and multiplied this. And what do we get? Well, we had the 5 halves, again, just like we had on the top, and we had the 7/3, and then we simplified. Now, I don't really care about the simplification. I really care about this here, because when we do that same thing over here, look at what we get. We get x over 1 times 2 over 5. All right? And what I really want to do is I want to compare this to this. And let me further emphasize that if we put that together, this would be 2x over 5, because we'd have the 2 times the x. You would normally put your constants out front, and 5 times 1 is 5. So this is really what I want to compare to this. Now, if you look very closely, remember the x is on the side, but the x could also be on top. That being the case, then it looks a lot like this. This is the 2 that's here is looking a lot like our a, and the 5 that's right here, whoops, the 5 that's right here, if I can highlight it, is looking a lot like our c. And what this told us is that the 2/5 came from x over 5 halves. In other words, we could just take that 2 that's right there and bring it underneath the 5. Well, that means we can do the same thing with the a. We can bring it underneath the c. So again, let me get an error from clicking on that. But now let me pay attention to this equation right here. And in fact, let me retype it one more time. And this time I'm going to put the x and the y back up on top so it looks a little bit more familiar. There's our x. And oops. There's our y. Okay, and again we're going to get an error. Okay, but the important thing is that I basically want to get rid of the a on top and get rid of the a on the bottom. And you'll see why in just a moment, but that's my object. Okay, so we know that all we've got to do is take that a out of the top and divide it into the c. So we're going to have the x divided by the fraction c over a, and then we can do the same thing over here. We're going to have y divided by c over b. All right. Well, again, an error because I don't have a, b, and c defined. However, this is just about the right form that we're going to want. Let me copy and paste it. I'm going to replace the c over a that's over here with a single number, and that number, or that parameter, is going to be a little a, and the parameter over here I'm going to call b. This is going to be our intercept-intercept form. All right. Now I'm not going to, and again it's going to yell at me at this point because I don't have little a or little b defined either. But I'm going to erase all of this stuff. Remember that you can always play the video back and see where all of this stuff came from. But what I want to now examine is this form. I want to see what happens with a and what happens with b. All right, so we're going to delete a bunch of stuff out here. Let's get rid of that. And let's put in a parameter definition where we're going to say a equals 1, and then we're going to let b equals 1, and all of a sudden that top equation is going to be happy. Not only is it happy, it actually graphs something. I'm going to put it third now. And what you'll notice is we've got the x-intercept being 1, which is indeed what a is, and the y-intercept being 1, which is indeed what b is. Now previously, when we had capital A and capital B, they weren't doing what we thought they should be doing. They ended up doing, quote-unquote, the reciprocals, and that's what little a and little b are. They're the reciprocals. All right. That being the case, let's go parameterize this now and see what it's going to do. But before I do that, let me, it looks like I've got my grapher outside of my window, so there it is. Let me go ahead and get the inspector open and color the line. Let's make it green again. Okay. And now we're going to go parameterize little a and see what happens. And so let's go over here. Stayed -4 for a change. -4 to 4, and we will go A1 values. Okay. All right, let's go see what happens. Let's play it. Well, this looks a lot like what we were doing last time. You're going to see exactly the same type of graph when we were doing the standard form. It's going to oscillate basically about this point. But notice the subtle difference here. Now little a is 2.5, and the x-intercept is 2.5. Let's check out another value. Okay. A is 3.2, and the x-intercept looks like it's about 3.2. See if we can get a nicer value going. There we go. A is 4, and the x-intercept is 4. So now A is literally, in this form, A is the x-intercept. And we can read it right off of the equation. Oh, well, that was something different. Now you can notice that when A goes to 0, it does become a vertical line. It's actually undefined, but it's basically very close to vertical, which is, I guess, a little different behavior than I was expecting from the standard form. This would also make a very good pendulum for physics. We could work something with this. The timing isn't quite right, but nevertheless it could be used. Alright, so you get an idea what A is. Let's just double check again. When A is a negative value, we come over here. So when it's negative 0.7, indeed the x-intercept is 7. Let's go ahead and just take a quick look at A equals 0. Now typically this means that we've got x divided by 0, and you can see the green line is missing. It's not there. So it's actually not graphing this particular point, and or this particular line, and that's because we're violating a mathematical law that basically says we can't let the bottom go to 0. And we're doing that, so it just, the graphing calculator says, oh, I'm not going to graph that then. But other than that, it's graphing all of the points we would expect. Well, let's go ahead and stop this and go play with B real quickly. And we should expect to see sort of a similar behavior now, that this should be the y-intercept. The B should be this value at all times. So let's see if that's the case. We'll animate that parameter and go from negative 4 to 4. Hit OK. And, oops, and hit the play button. And indeed, we can see, let's go ahead and stop it right here. B is negative 1.11, and it looks like the y-intercept is negative 1.1. Let's play it. Negative 1.9 for B, negative 1.9 for the y-intercept. Negative 2.9 for B, and negative 2.9 for the y-intercept. All right, and let's look at a couple of positive values. Taking a while to get there. Okay, and there's again B equal 1, y-intercept of 1, B equal to 2, y-intercept of 2, and so on down the line. And guess what? That's it, because there's only 2 parameters. That's all there is to look at. So that is the equation. All right, let me go ahead and stop this, and let me go ahead and give you a couple of quick equations just so that you can see how we would do this. Suppose I had the equation already in standard form. Suppose I had 3x plus, oh, I don't know, 2y, well, let me pick something nicer right now, 6y equals 12, okay? Now, this is still going to graph this. We're not interested in that. What we're interested in right now is, could we graph it just by looking at this equation or by a quick manipulation? Well, let me turn it off and tell you that the quick manipulation, again, is to get this to be a 1. That means we're going to divide every term by 12. If we do that, we're going to get 3x over 12 plus, and you might be wondering why I'm going downstairs when I do that. If I do 4y over, well, actually I did it this time, 6y over 12, that worked out, and we'll put equals, and then this would be 12 over 12. Okay, you can see we're getting the same line that we saw before, but again, this is not what we're interested in. We're interested in simplifying this down. Notice that 3 goes into 12 4 times, so this would be x over 4 plus, and 6 would go into 12 twice, so we'd have y over 2 is equal to 1. And there would be the x equals 4 for the x-intercept, and the y-intercept being 2, Goes right through here. So looking at this equation, we could predict those 2 points and we can graph them. Specifically, we would go ahead and put in a point. Remember, we have to go up to here. Okay, I'm not sure why it's giving me a hard time here. It does this occasionally. Let me see if I can switch back and forth and get its attention. Okay, there we go. All right, and so we would put in the equation. Somehow doing the same thing again. Sorry about that. Let's try it one more time. Not quite sure why it's being very difficult. There we go. That's what I'll do from now on. Okay. So we're going to grab our point and get rid of the parameterization stuff, and we are going to put in the point, let's see, 40, and that's from looking at this particular value, okay, which gives us a point right here, right over there, and then we're going to copy paste this and put in the point 0, 2. So let's come down here and make that a 2. So there is our 0, 2, and then you would draw a line through this. When you drew a line through this, you'd get that. Okay? So that's how you could graph this. Now this was a particularly nice one because the divisions worked out very nicely and gave you ones immediately. Let me show you one other one that isn't so pretty. In fact, we're just going to do 3x plus 2y equals, well, let's pick 11. That's pretty ugly. Okay, well, there's the line, and again, it's going to be a little bit off of the graph. I tell you what, let's pick, instead of 11, let's pick 5. Oh, that's much better. Okay, because we can see these points, and they're ugly points too, but they're points that we can figure out pretty easily, because now we can do this in 2 steps. We can take the 3x divided by the 5, then add 2y divided by the 5 is equal to the 5 divided by the 5. That's what's going to get us the 1. That tells us what 2 have divided by was the 5 that was right there, because we want to get this to be a 1. All right. Now, remember the little trick of taking this from the top underneath the bottom number? Well, that's now what we're going to utilize. So we're going to have x over 5/3 plus y over, where do we go, 5/2 is equal to 1. Okay, and again, we would not interested in graphing these for the graphing calculator. We want to graph these by hand. So what points am I going to graph? Well, this is telling me that the x-intercept is 5/3. The x-intercept is a place where y is equal to 0, and the x-intercept, the x value, is 5/3. So we're going to put in 5/3 there and 0. And lo and behold, we should have a point right here. Let's hope that works out well. And now we're going to copy the other y-intercept point from the other line, and that is going to be a x equals 0 point, but it's going to be y equals 5/2 now. So let's change the 2 in this to 5/2, and that's going to get us a point over here. We would draw a line through that. That should be our line. Let's verify it by putting that equation on, and there it is. There's the line that's basically that equation there. So all we had to do is do a couple of quick tricks, divide by 5, and bring the number that is on top underneath. If you think about it, once you get used to it, you could really do this step in one step, really. You can bring the 5 underneath and then bring the 3 underneath the 5 immediately and write this first term. And then you can do the same thing with this one. You could take the 5 and bring it underneath, and then the 2 underneath the 5, and just make that a 1. So that'll give you this equation, and within one step you know what the x and the y intercepts are. All right, well, that's my pitch for learning the intercept-intercept equation, which is x over a plus y over b equals 1. You might wonder how I came up with this. Well, they teach this in Calc 3, except they have a three-dimensional equation. They'll have x over a plus y over b plus z over c, and tell you what, at this point I'm not going to tell you what that is. You might suspect what it is, but I'm going to let you either play with it on a graphing calculator, or maybe you guys can request it and I'll do it for you. Eventually I'll probably do it, but for right now I'm going to let you stay curious. But that's it for our intercept-intercept equation, and that should work for either Algebra 1 or Algebra 2. Alright, let's switch over to the final screen here. We were studying linear equations, the intercept-intercept form that you do not find in the, at least in most books that I've ever looked in for Algebra 1 and Algebra 2, and we were examining what A and B did. Alright. I'm from Tutoring Enterprises. That's my little business. My name is Joe Maciarz. My website is at www.tutent.com. My email is at tutent@neb.rr.com, and my phone number is 402-421-3536. I do online tutoring and I do in-person tutoring. If you found this video useful, feel free to contribute $1 to my PayPal account, and if you found it more than useful, don't worry about the dollar. Give me a call and set up an appointment, and we'll give you a little hand with whatever you're working on, math, physics, or chemistry, and maybe even some computer stuff if you're really stuck. That's about it. I hope you enjoyed the video, and I hope you learned something. I know this is something different than what they normally show you, and this is a lot of what I can give to you as a tutor. I know a lot of things. I know how to put things together, and I know how to come up with some things that they don't tell you in the book that make life easier. I specialize in trying to get you guys to learn this stuff in a way where you can remember it long term. Ask your parents or your grandparents if they remember any of these equations, and the answer will probably be no. I try to teach you these things in a way that makes them last a very long time. I don't know if they'll last so when you're a parent or a grandparent, but they will last longer than your parents had their equations in their head. So, like I said, if you need some help, give me a call, and we'll go from there. Thanks for watching the video, and well, I hope you have a great day.